In this review video, we're going to talk about solving logarithmic equations. We already talked about how to solve exponential equations. So we've had an exponential look like this. We use this thing called the one-to-one property to kind of eliminate the exponent parts and just say C is equal to B. And we're going to be able to use the same type of strategy for logs because logs and exponentials are similar. All right, so we can cancel out the logs and just get C equals B again. All right, we have to get the single log with the same base on both sides, just like we did with the exponentials. So in this case, all right, we're given this equation, but we know they're both log base 5, and just one on each side, so now I can kind of cancel these out and just look at the insides being equal. Now I'm going to move this 2x to the other side by subtracting 2x from both sides, move this 1 over here by subtracting 1 from both sides, and then divide by 2. All right, so that's my final answer, x equals 3. This problem starts off the same way. I have log base 8 on both sides, so I can kind of just ignore those and just look at the insides. I'm going to subtract 3x from both sides. I'm going to add 3 to both sides. And I get x equals -6. And most of the time, you'd be done, but logs are this kind of special type of thing where I can't plug everything into a log, so I have to make sure that this works in the original problem. And if I plug -6 into this expression, 4x minus 3, well, x wants to be -6. That gives me -27. And we saw before when we were talking about the domain of logs, I can't put this negative number into my logarithm. So this -6 actually doesn't make sense. You can't put a negative inside of a log. So the answer is no solution. All right, so even though we got an answer, this is called an extraneous root because it doesn't actually work in the original equation. It works in all this stuff in red, but it doesn't work in this original equation up here. So we had to say there's no solution. We crossed that possible answer out. All right, so that's our general strategy for solving log equations. Just make sure you do that extra step we didn't have to do with exponentials of looking for extraneous roots.